Okay, second part of part 8. Number 10. Solve each equation by graphing. Round the answer to the nearest tenth. Write the equation of the functions you graphed first. Okay, number 10. 9 raised to the x power equal to 11. We can write it as two equations. The first equation, we can write, oh, here's the exponential function. We can write like y equal to 9 raised to the x power. The second equation, the other part, so y equal to 11. We're going to graph these two to find out the solution of the equation, right? So the first we're going to graph y equal to 9x. When x equal to 0, so 9 raised to the 0 power is 1. So when x is 0, the y value is 1 right here, the point. Okay, what about x equal to 1? When x equal to 1, the y value is 9 raised to the first power, right? Power of 1 is still 9. So 1, 9 is the second point. 1 is here. The x value is 1. The y value is 9. 9 is between 8 and 10. So it should be here. Okay, the second point should be here. The third point, when x equal to 2, 9 raised to the second power, or 9 squared. Oh, this is 81. 9 times 9, 81. Oh, it's too high. It's some point. Oh, way above. Go 81. I don't even know where's the 81. Because here's 12. 12, 81 is way above. So we don't have room, but we can we can graph it like this, going up like this. Yeah, this is the first equation. Okay, second equation, y equal to 11. Y equal to 11. Y equal to 11. 11 is right here. Y equal to 11. This kind of function, there's no x, so the graph never touch. So the graph never touch x-axis. So it's horizontal. On this line, we don't know the x value. Well, x can be any value. But the point on this line, the y value is always 11. So now, the intersection is the solution. This solution x equal to what? X value is right here. 1 point something. It's like a 1.1 maybe. So this one, when we graphing solve the equation, is the least accurate one. So we're going to write out x almost like 1.1. We're guessing. It's a little bit more than 1, right? So if your answer is a little bit different from mine, that's okay. A little bit more than x, that's good enough. So almost 1.1, okay. To the nearest tenth, right? Tenth, that means 1 digit from after the decimal point. Okay. Number 11, equation. Again, we're going to write out y equal to 12 raised to the x power. Another equation, y equal to 120. Okay, y equal to 12 raised to the x power. The first point is going to be when x equal to 0. When x equal to 0, the y value is 1. Wow, look at the graph. Here's 120. Oh, we can graph the second equation. It's just like this, right? Okay, this one, yeah. 120, 1, 2, 3, 4, 5, 6. So each increment is 20. 40, 60, 80, 100, 120. Okay. Now, when x equal to 0, the y value is 1. 1. X equal to 0, the y value is 1. 0, 12 raised to the 0 power is 1. Where is 1 on the y-axis? It's very, should be right here, something like this. It's very low. Okay, when x equal to 1, the y value should be 12. 12 is a little bit, because here's 20, right? So 12 is a little bit above. Okay, when x equal to 2, 12 times 12, so 12, oh, this number going to be really big. It's 144. 144, 144. So this is 140. 144 when x equal to 2, something like this right here. So the graph going to look like this. Solution is the intersection. This one. What's the value of this point? Oh, almost 2, right? Almost 2. So maybe we can write x almost, maybe 1.8 or 1.9. Let's do 1.8, right? Hmm. 12 raised to maybe 1.9. 12 raised to, I'm checking the value with the calculator. 1.9. Let's do 1.9. 1.8 is a little bit too small. Okay, 1.9. Good enough. Okay, last two questions, number 12 and 13. Word question, word problem. Number 12, a town with a population of 600, or the initial value 600, expected to grow at an annual rate of 5%. Write an equation and find the number of the years is expected to take the town reach to the population 900. Okay, equation, y equal to initial value 600 and the growth rate. The growth rate, so we're going to change 5% to a decimal. That's 5 divided by, so this is percentage is just 5 divided by 100. This is going to be 0.05. So 5 divided by 100, that's 0.05. So, and then the growth rate, so you're going to use 1 add 0.05. So that is 1.05 raised to the x power. So that's the equation to model the growth of the population. So now we're going to figure out when x equal to what? The population, what here? The population going to be 900. So we can set up this, there's not enough room. So we're going to set up a 600 times 1.05 raised to the x power equal to 900. Divide both sides by 600, so 105 raised to the x power equal to, what is 900 divided by 600? Because we're going to get rid of the 600, so I'm going to divide both sides by 600. By 600. So this is going to be 1.5. At this point, you haven't learned logarithm yet, log function. If we learn a log function, we can figure out x right away. But we haven't. So we're going to try 1.05 times itself. How many times? And then going to reach 1.5. I'm thinking of oops. You can do this 1.05 times 1.05. 1.05 times 1.05, this is 1.1. Keep multiplying, keep multiply 1.05, 1.15. Oh, it's going to take a while. Or you can use this. So 600 times 1.05 equal a number. And you're going to keep multiplying to keep. And then you need to remember how many times you're going to multiply 1.05, and it is equal to 900. I have a little easier way to figure out 1.5. I'm going to use natural log. You never learned it yet, but the power is going to be 8.3. So x equal to 8.3. So the year is going to be 8.3. That means we're going to take at least, we're going to round it maybe 9 years. 8 years is not going to reach 900. So we have to round up. So this is going to be 9 years. This kind of word question, if you don't know how to use log to solve yet, then you just multiply 600, multiply by 1.05. You keep multiplying 8 times. It's getting closer to 900, but you have to multiply one more. So at the year 9, the population going to be a little bit more than 900. Okay. Now number 13. How long will it take 20,000 earning 3.5% annual interest to double in value? You just use 20,000 times 1.035. I just changed the 3.5%. So this means 3.5 divided by 100. This equal to 0.035. And then I add 1. So this is a multiplication. Let me erase this. So the function going to be 20,000 times 1.035 raised to x power. And you're going to figure out what is x. At this level, you can just keep multiplying. So 20,000, use calculator. So multiply this, and then multiply again and again, and you keep a track. And then until you reach the point, the value going to double, going to be 40,000. Until you reach that number. So this equal to 40,000. So basically you're going to solve this. You're going to solve this function. And I can use x equal to what? I'm gonna use the log function to figure out. Natural log 2. 0. I divide the equation both sides by 20,000. 20,000. And then this is equal to 2. Equal to 2. And I'm going to use natural log 2 20 years. So x equal to 20. 20 years. That makes sense. You put the 20,000 in the bank and you leave it for 20 years. It's going to double the value. But the interest rate is pretty slow. Pretty low, 3.5. So you haven't learned the logarithm function yet. So you have to multiply, keep multiplying 20 times. Oh, but this is asking you to use a graphing calculator. So you can use decimals. I can't show you during the video recording at this point. But you do the graph and you can find the answer.